Come on, start recording, you cheeky sort. Yeah. Okay. So on Wednesday, you all can hear me, yes? On Wednesday, we finish off here, right? So from here, we know this is last Wednesday notes. If you all can go to the last Wednesday's notes. So we know from here, how do I label it? I can't remember now. So we have it as shear XZ, okay, is our maximum shear. Okay, that is our shear XZ. Okay, so our XZ plane, our out of plane, has the what? Maximum shear. Okay, so like before, we have formulas calculating maximum shear. So when this case, okay, when you have this case, you realize that the shear XY max is also equal. So if we were to label this stress max, this will be stress mean. We know this will be equal to stress max minus by stress mean divided by 2. Okay, and we are aware that this is also our what? Out of plane. Okay, so you can see for 3 conditions, one condition, the maximum stress is in plane, the other 2 is out of plane. Okay, so let's start off as drawing 3D Mohr circle. As I said, 3D Mohr circle is not difficult at all. Okay, so I've just posted this on Avenue to Learn. If you all can get this element, please. Okay, so this is our element, example number 1. So we have to follow the transformation that we are given over here. Okay, so this is our X, this is our Y. Is it on Avenue? Can you get it from Avenue to Learn, yes or no? Yes? No? Yes. Okay. And this is our what? Z. Okay. So first thing of all, like before, label this as your X. Label this as your Y. And label this as your Z. Okay. So immediately from here, we can see that your normal stress Y is equal to positive 30 psi. Your stress Z is equal to positive 120 psi. Your stress X is equal to 0. And we have our shear YZ is equal to shear ZY. And this will be equal to 70 psi. Okay. So from here, we start constructing 3D Mohr circle. And as I said, it's not difficult. This is our x-axis. Okay. So this is our minus 60, 40, 20, 0, 20, 40, 60, 80, 100, 120, 140, 160, 180. This represents our normal stress. Then we will proceed to our shearing stress. Okay, so our shearing stress, we have 20, 40, 60, 80, 100, 120. Now the shear stress at the top element rotating clockwise, minus 20, minus 40, minus 60, minus 80, minus 100, minus 120, element rotate in the anti-clockwise direction. Nothing new. It's exactly the same like what? 2D Mohr circle. Okay. Once we have this, we draw our 120 line. And then we draw our positive 30 line. Okay. And then from here, we have 17, the shear. Whether is it positive 70, negative 70, we just draw a 70. Okay, that's our 70 now. So I'm going to label this over here. This is our stress Z line. This is our stress Y line. And this is our stress X line. Okay. So the next thing that we will proceed is we want to find where is our point Y. Okay. Let's look at our point Y. Okay. At our point Y, we have what? Positive 30, and the element is rotating in an anti-clockwise direction. I repeat again, the element is rotating, so Y, right? So this is Y surface. The element will be rotating anti-clockwise is because of this arrow going upwards. So this is our point Y. Oh, I got it wrong over here. 1,000 apologies. It's minus 30. Woo! Okay, not minus 40. Okay, so 70 is correct. So over here, this will be your point Y. Okay. And then on your point X, your point Z, next we're going to look at Z. It's at 120. And then the element, okay, based on this 70 over here, is rotating in a clockwise direction. So this is our point Z. Then from here, we are going to draw a straight line. Okay. So we are going to do some very basic calculation like what we have done before, but now we have to declare the plane that we are dealing with. So now we are dealing with YZ plane. Okay, you declare that we are dealing with YZ plane. So you calculate the stress average about the YZ plane is equal to stress Y plus by stress Z divided by 2. So this will be equal to 120 plus by 30 divided by 2. This will be equal to what? 75. Let me write below. So 120 plus by 30 divided by 2. This is equal to 75 megapascal, PSI, pounds per square inch. So from here, you draw your 75 line. Once you have constructed your 75 line, you declare that over here is your point O. Okay. And we are aware, if we were to label them, okay, we are aware that the distance from here to here, this is known as our stress average for the XY plane. Okay. Immediately after that, we calculate. So this one, we know that this is the center of circle. The next edge is our shear max in the YZ plane. So this will be equal to, you immediately take the shear stress. Okay, the shear stress is 70 squared. And the next thing that you have to remember, why 70 squared? Because the distance from here to here, this distance is what? We know this is immediately, this is equal to what? 70. And the next thing that we need to find out is the distance from here to here. And this distance will be 120 minus by 75. So 120 minus by 75 is equal to what? 45. Okay. Why are we doing that? At the end of the day, what we are interested to find this distance over here, which is the radius of your circle. Okay. So this will be equal to 45 squared. Okay. This will be equal to plus 45 squared. So 70 squared, 70 squared plus by 45 squared, square root the whole thing, 83.216 psi. Immediately from here, you calculate your principal stress, or we call it stress 1, 2, along the YZ plane. So this will be equal to what? So before I go on, this is the radius of the circle. We did not learn anything new, but we apply different things, okay? So this will be 75 plus or minus 83.216, okay? So 75 plus by 83.216 is equal to 158 positive 158.216. And then the other value will be 75 minus 83.216 is equal to 8.216, both PSI. So from here, okay, from here, we have our principal plane now, or our principal stresses. So now we can construct Mohr circle. Okay, so we have minus 8. Okay, I'm just eyeballing. And then we have what? 158. 158. So 160 over here, 158, somewhere around here. Again, this is eyeballing. And then we have our shear stress, which is what? 83.216. 83.216 is about here. And then I'm going to stretch it out, 83.216 about here. Okay, I think I have to squeeze this down a bit. Okay. Now, for this problem, we don't know what is in plane and we don't know what is out of plane. Does that make sense? Because it represents a what? A cube, right? So we don't know what is in plane, what is out of plane, but it's fine. Okay, so what we label now, we are going to label this. This is our YZ what? YZ plane. Okay. Are we okay? Okay. In 3D Mohr circle, we label this as your stress A. We label this as your stress B. Okay. So this is also equal to stress 1 and it's also equal to your what? Stress 2. They're the same thing. Are we clear? Okay. But in 3D Mohr circle, I never ask why. I'm obedient. I just follow the textbook. Okay. So you call just one side stress A, the other side stress B. Does not matter which side is A or B, but label them as A. If you want to flip, one side is B, the other side is A, go for it. I don't know why my name is Eugene from the beginning. You know why I call your name? No, right? Any idea what's the meaning of Eugene? In French, it's not pain in the ass. Shit, you guys have no humor today, man. What's wrong with you? Okay? No, it means, where is my French exchange student?